Welcome to the feature demonstration of VMware vSAN. In this video, we will focus on the Storage Policy-Based Management, or SPBM capabilities of vSAN. SPBM from VMware vSAN enables precise control of storage services, like availability levels, capacity consumption, and stripe widths for performance. Using the vSphere web client, storage policies can be created, managed, and assigned to virtual machines and individual objects, such as a virtual disk. Storage policies can also be reassigned if the application requirements change without any downtime and without migrating virtual machines between data stores. SPBM is also capable of assigning and modifying service levels with precision on a per virtual machine basis. Before we examine how an SPBM policy determines the data placement of virtual machine objects, let's take a look inside a virtual machine. A virtual machine contains various objects. Objects are comprised of chunks of data, known as components, and can grow up to a maximum size of 255 gigabytes. The number of components representing each object is determined by several factors. Level of failures to tolerate, failure tolerance method, RAID 1 mirroring, or RAID 5/6 erasure coding. Size, 255 gigabytes per component. Stripe width and rebalancing efforts. As an example, a 100 gigabyte virtual disk with a FTT of 1 and RAID 1 mirroring would consist of two 100 gigabyte components striped across two hosts. Some virtual machines might have multiple disks with varying levels of service. For example, in a database server, the operating system can be replaced with relative ease. However, the database undergoes constant updates and changes. The virtual disk containing the database can use a policy that stripes across more drives than the operating system virtual disk. We will now demonstrate the SPBM capabilities of vSAN by creating a new storage policy containing RAID 5 or erasure coding fault tolerance method. Erasure coding offers lower capacity consumption while providing the same level of availability compared to mirroring. Let's create a VM storage policy, along with an additional one by cloning an existing policy. Click on VM Storage Policies to create a VM storage policy. Name it RAID 5 erasure coding, and click Next. Select vSAN as the provider, and add a rule of primary levels of failures to tolerate with a value of 1. This will distribute the components that make up the actual object, the virtual disk, etc. Now the failure of a disk or the entire host can be tolerated without any data loss. Let's add a rule failure tolerance method, and this time, let's choose RAID 5/6 erasure coding capacity. Click Next, and click Finish. A storage policy is applied when creating a new virtual machine. The storage policy for existing virtual machines can be changed at any time, without disruption or downtime. Now let's edit the storage policy on App1 virtual machine. We can apply a storage policy to an individual object, like to hard disk 1 here, or we can apply to the entire virtual machine by hitting the Apply to All button. Finally, let's check the compliance status of the virtual objects and their vSAN components. The list of virtual objects and their vSAN components placement can be viewed by going to the Monitor tab and then to the vSAN section. Go to App 1 and then click on Hard Disk 1. Under the RAID 5 policy, we can see that these 4 components are distributed across hosts to comply with the assigned policy. As we can see, App 1, the VM home directory, and Hard Disk 1 are all compliant. Storage Policy-Based Management is the foundation of the VMware SDS control plane and provides a single unified control plane across a broad range of data services and storage solutions. This framework helps to align storage with the application demands of your virtual machines. This concludes our discussion on the SPBM capabilities of VMware vSAN. Thank you.